Hey there, curious minds. Welcome to another episode of I Wonder, the show where we explore the questions you've been wondering about. Today's question comes from Jason. Jason asked, does a bigger brain make you smarter? What a brainy question, Jason. It's tempting to think that the bigger the brain, the smarter the person. But the answer isn't that simple. Let's dive into the science of brains, intelligence, and whether size really matters.
Wow. Uh-oh.
How big are human brains? The average adult human brain weighs about 3 pounds and is roughly the size of 2 clenched fists. It contains around 86 billion neurons, which are the cells that carry information and allow us to think, feel, and act. But here's the twist. Humans don't have the biggest brains in the animal kingdom. In fact, sperm whales have brains that weigh about 17 pounds. And elephants' brains are about 10 pounds. If brain size alone determined intelligence, whales and elephants would be far smarter than humans. But that's not the case. The secret to intelligence isn't brain size. It's how efficiently the brain's neurons connect and communicate. Think of your brain as a supercomputer. It's not just about how big the hardware is, but how fast and organized the processing system works. Neurons in your brain form trillions of connections called synapses, which allow information to flow. The more connected and efficient these networks are, the better your brain can solve problems, adapt, and learn new skills.
Oh.
For example, Albert Einstein, one of the most brilliant minds in history, had a brain that was slightly smaller than average. What made him exceptional wasn't the size of his brain, but the unique structure and density of certain areas, particularly those involved in mathematical reasoning and imagination. This shows that the quality of your brain's wiring matters far more than its size. Okay, but what about brain size in animals? Let's explore why some animals have such massive brains. Whales and elephants have large brains primarily because they need to control their enormous bodies. A bigger body requires more neurons to manage movement, sensory input, and organ function. Humans, on the other hand, actually have a much bigger brain-to-body ratio, which measures the size of the brain compared to the overall body size. This ratio is one of the reasons humans are capable of advanced thinking, creativity, and problem-solving. Even within the animal kingdom, brain organization plays a bigger role than size. For example, crows and parrots have relatively small brains. They're incredibly intelligent, capable of solving puzzles, and even using tools. Their brains are densely packed with neurons, making them highly efficient. Does brain size matter in evolution? While brain size isn't the sole measure of intelligence, it has played a role in human evolution. Early human ancestors like Australopithecus had brains about 1/3 the size of ours today. Over millions of years, the human brain grew larger relative to body size, allowing for more complex thinking, language, and creativity. However, what truly set humans apart wasn't just the size of our brains, but the development of specific regions, like the prefrontal cortex, which handles planning, decision-making, and problem-solving. Interestingly, as our brains grew, they became more energy efficient. Your brain uses about 20% of your body's energy, even though it makes up only 2% of your weight. That's like having a small but incredibly powerful engine that requires a lot of fuel to run. How fast does the brain grow? The brain grows remarkably fast, especially during the first few years of life. By the time you're born, your brain already contains almost all the neurons it will ever have, about 86 billion. In the first year after birth, your brain doubles in size, forming trillions of connections as you learn to move, communicate, and explore the world. By age 3, your brain is about 80% of its adult size. Even though the brain reaches its full size by your mid-20s, it continues developing and adapting throughout your life. The last part to mature is that prefrontal cortex we mentioned, which does explain why teenagers sometimes struggle with impulse control and decision-making. It's all part of your brain growing and really fine-tuning itself. Do we lose neurons as we age? Yes, but it's not as scary as it sounds. Starting in your 20s, certain parts of the brain, like those involved in memory, gradually lose neurons. However, the brain is incredibly adaptable through a process called neuroplasticity. Even as neurons decrease, the brain can strengthen existing connections and form new ones to maintain its efficiency. Some areas of the brain, like the hippocampus, which is the area responsible for memory, can even produce new neurons throughout life. This process is called neurogenesis, and it shows that staying mentally active, eating a healthy diet, and exercising can help keep your brain sharp as you get older. Here's some fun facts about brains. Did you know your brain generates enough electricity to power a small light bulb? It's true. Your neurons communicate using tiny electrical signals, and when billions of them fire at once, they produce measurable energy. Here's another cool fact. Your brain is about 60% fat, making it one of the fattiest organs in your body. That fat plays a crucial role in insulating neurons, helping them send signals quickly. Brains also have an amazing ability to change and adapt throughout life. This flexibility, known as neuroplasticity, allows you to learn new skills, recover from injuries, and even form new habits.
Bravo! Bravo!
So, to answer Jason's question, does a bigger brain make you smarter? Not really. While brain size plays a role in evolution, intelligence depends much more on how the brain's neurons connect and communicate. It's not about how big your brain is. It's about how well it works. Thanks again to Jason for such a thoughtful question. And remember, if you have a question you're curious about, submit it on our website, iwonderpodcast.com, and we might just feature it in our next episode of I Wonder. Until next time, stay curious and keep wondering.